Now, the azimuth of Polaris is actually even easier. So we're just going to add this as a really quick addendum onto the latitude by Polaris. You can do a compass correction off of Polaris just like you can any other star. You can take its bearing and use that to find what your gyro error is or what your deviation is. And in those situations, you just take the same table we were working with, because I didn't mention it, but after A1, A2, all of that, at the bottom here, we've got the azimuth tables. And all you got to do there is you follow your column like you were before and compare it to your latitude, and that will give you the true bearing of Polaris. And you can see in all these options here, it never goes more than 2 degrees away from due north anyway. It's only ever like 0, 0 or 0.9 or something, and then here it gets at most to like 358.4. So it's always almost perfectly due north. So if we took the problem that we were doing before, and the question wasn't asking our latitude by Polaris, but the azimuth of Polaris, we would still have to take LHA. We actually wouldn't need HO anymore because we didn't even measure the height of Polaris. We only measured its bearing. So you would calculate LHA like we did before. You would come to our table again, and you could see we were using the 80 to 89 column. We follow that all the way down to the azimuth section, and then it's compared to latitude. So our latitude was 25 degrees, thereabout, so we'll use 20 instead of 40. Follow that row across, and right there, 359.3. So in this problem, when we got the height of Polaris, its true bearing was 359.3 degrees. And if you wanted to then find your gyro error, you could just compare that to what you measured off of your compass. Azimuth of Polaris, even easier than latitude by Polaris. You just find your LHA, and you have that column intersect the value of your latitude, and you get the azimuth right there. Makes your life very easy.